Remember how the internet was a few years ago? Films took all night to download. Social network pages took several minutes to update. Online games froze terribly. And this is only a fraction of the troubles we all experienced. Today, technology is on a completely different level, and the internet is no exception. Despite the fact that it's already quite fast, I've come up with one question. What would happen if we sped up the internet to infinity? To discuss accelerating the internet, we need to understand how it works. By 2020, the number of people using the internet now exceeds 4.5 billion. Given the world's population, that's more than half of all the inhabitants of the Earth. And when there's huge demand, you need to offer something in return. With so many users, it could be a huge problem if the data transfer rate was too low. So the average internet speed in Taiwan in 2019 was about 85 megabits per second. In America, 33 megabits per second. And in Australia, 16.3 megabits per second. Despite the huge differences, the inhabitants of these countries can all easily watch videos on YouTube, read online books, and watch series. So what does this speed depend on? There are several technologies used to transmit information over an internet connection. One of them is made through a twisted pair cable. Inside this, there are usually 4 pairs of conductors through which the signals that encode data pass. Now, there are many types of cables based on twisted pairs, but I won't bore you with unnecessary information. The average data transfer rate with this method is from 10 megabits per second to 10 gigabits per second at a distance of up to 100 meters, or about 328 feet. Another way to transfer data is wireless, which each of you is highly familiar with. There's no need to mess around with wires and set up a bunch of everything. You just enter your password and you're ready to go, with access to the internet. Convenient, right? But information, in this case, isn't transmitted simply through the air. The Wi-Fi connection isn't independent, and the router also has a data source. In fact, it's a transmitter that distributes and receives radio waves in a certain range, between 2.4 and 5 gigahertz. But all of this isn't as important as the speed at which information transfers. When using a wireless connection, it can range from several tens of megabits to 11 gigabits per second. In the case of a Wi-Fi connection, this directly depends on your distance from the adapter. The closer you are, the better your signal, which means a higher speed. Another popular way of transferring data is called fiber optic communication, and the principle on which it operates is quite simple. Light pulses act as the information carriers, and optical fiber is used as a transmitter. And it seems that the person who created it gifted the world a real miracle. So what is its value? It has a large bandwidth. Namely, it transfers data at a speed of up to several tens of terabits per second. Moreover, with this, there's no problem with huge distances and electromagnetic interference. It seems unrealistic, but optical fiber can really do it. Here's a real-life example for you. The Maria transatlantic cable connecting the USA and Spain transmits data at a speed of about 160 terabits per second. The cable length is 6,600 kilometers, or about 4,100 miles. In addition, it lies under the water. A real superhero from the world of technology, but that's not all. In addition to transmitting data over the internet, its fiber optic cables are also used to transmit telephone signals and cable television. So, if this technology is so unique, perhaps it could push the internet to the limit. Let's check it out. A major breakthrough in the field of high-speed data transfer was made by Japanese researchers in 2015. they were able to develop and successfully test the world's first system with a bandwidth of 2.5 petabits per second. To understand how much this is, just imagine, at this internet speed, 10 million people would be able to watch 8K video at the same time. As you might have guessed, I'm talking about the same optical fiber. Another way to set such a record simply doesn't exist. These results are more than 1,000 times greater than the capabilities of today's wireless networks. Of course, such technologies aren't created quickly. Scientists spent 4 years on its development before presenting the results to the public. So, is this speed the limit? As it turned out, no. The same Japanese scientists, together with KDDI and Sumitomo Electric Industries, achieved a data transfer speed of about 10 petabits per second, or 10 to the 16 bits per second. Such a figure is sure to please major providers who've already begun dreaming of a monetary future. But just imagine the joy of ordinary people. Endless traffic, round-the-clock TV shows, games with zero latency. But wait, the results obtained thus far are still only experimental, and they're unlikely to reach our home internet in the near future. But what did they do with the optical fibers to achieve such a high data transfer rate? To start, let's determine what this optical fiber is all about. In a broad sense, it's a thread of transparent material that carries light within itself. Single-mode optical fiber has one channel, and it can only pass one ray of light through it at a time. But there's another type of fiber, multi-mode optical fiber, and through this, several separate rays of light can pass at the same time. To fully understand this process, let's imagine lines of different colors. Each of them is a separate light stream. If you run them through multi-mode optical fiber, they'll travel internally and independently of one another. It's like if you and your neighbor lived in a multi-story building on the same floor, but would go down on opposite sides of the stairs. In this way, in a single fiber, bandwidth can be increased. Different information streams are transmitted independently of one another. Internet speeds increase. In practice, optical fibers can receive a large number of light rays, up to several hundred. It was in this way in 2012 that Japanese specialists managed to achieve a speed of 0.1 petabits per second. Using Netflix as an example, such a speed would allow 5 million people to use the service at one time. However, this isn't the technology that will accelerate the internet to 10 petabits per second. Something else is needed for this. To increase the speed of data transfer, it's necessary to increase the bandwidth of the optical fiber. And to increase this, you need to increase the number of optical channels, right? This can be achieved by increasing the number of fibers in one cable. In theory, this seems incredibly simple. But scientists have been working on this technology for years, and therefore there's still more work to be done. But back to our 10 petabits per second. According to the technology that I've been speaking about, this type of data transfer rate has been implemented, and today it's the ultimate one. Through one cable, 114 light streams passed. Each of them consisted of 739 wavelengths. As a result, 84,246 waveforms had to travel through the optical fiber to create the fastest internet in the world. This is difficult to imagine, as it is to imagine a huge highway with 84,000 lanes. A truly great achievement. For now, our progress towards this rate remains at an experimental phase, but I'm sure scientists are already working on the development of a network for the future that will be available to us all in every corner of the planet. However, we still have to wait a few more years. For now, we'll continue watching movies 5 minutes at a time, waiting for new segments to buffer, playing high-latency games, and restarting Wi-Fi routers. But soon, this will all change. And if this video doesn't freeze while you're watching it, be sure to like it and share it with your friends.